Okay, let's look at this problem. Well, we might think we need to use the compound equations for this problem, but actually we don't need to do that. Let's first start talking about what an acute angle is. An acute angle means it's between 0 and 90 degrees. So both x and y are between 0 and 90 degrees. So that's something that we know right from the beginning of the problem. Okay, the cosine of x plus y is equal to 0. Well, 0 is a very special number, and remembering that the cosine is the x-coordinate on the unit circle, so we know that we are at the point where the x-coordinate is equal to 0, and that is 90 degrees. So we know that x plus y has to equal 90 degrees. And remember, that makes sense. If they're both acute, they might add to 90. So that makes sense. Now the tangent of x minus y is equal to the square root of 3. So this one is a little bit more complicated. Remembering that the tangent of an angle is equal to the y-coordinate over the x-coordinate on the unit circle. Sometimes we write that as the sine of the angle over the cosine of the angle in the unit circle. So we notice that we have root 3 over 1. So as we think about our coordinates on the unit circle in the first quadrant, since these angles are acute, we notice that the angle 60 degrees has a tangent equal to root 3, because square root of 3 over 2 divided by 1/2 equals square root of 3. So we know that x minus y, the angle here, is equal to 60 degrees. Now we have not our answer quite yet, but we have two equations with two unknowns, so we can solve that system for x and y. You might use substitution, or you might add the two equations, which is what I'm going to do, because I notice when I add the two equations, I get 2x is equal to 150 degrees, so x is equal to 75 degrees. And once we have x, we know by using either equation that y is equal to 15 degrees. And yes, those are both acute angles, so we are all set.